Pause. So you're going to send me one that has
Yeah, I'll come up with a sheet that has those listed in there.
yeah.
6.4A is looking at special things to factor, and the most of the special variety is where when we were back in chapter 5, we had things like x minus 6 times x plus 6, and we multiplied those out. What did we get if we FOILed that?
The x squared.
Minus 6x plus 6x, because x times 6x is 6x, and negative 6 is a negative 6, and negative 6 times negative 6 is a minus 36. And when we put our middles together, what happened? I get x squared, they cancel each other out, minus 36. So I had this special case that's taking place here where there is no middle term. You don't have any middle term at all in this one. But what we have is what's called the difference of squares. So we have a difference of squares. And what you happen to have with this is that if you notice, the first part is a perfect square and the last part is a perfect square. Now this is new stuff, so those of you who are working on other things, and so you get caught up with stuff, you need to pay attention to this part. So if I have this piece and I want to factor it, what I simply do is x is going to be x and x, because there is no way in which I can use any of the techniques I've been using with this one. But I know 36 is 6 times 6. Because it's a subtraction, or a subtraction in the center, that means one is positive, or one's negative and one is positive, and that's what it happens to factor to. Now, if I have differences of squares, yes?
When you do the x minus 6 and x plus 6, does it matter which one's minus and which one's plus?
Nope.
Okay.
No, my pattern in here doesn't make a difference. I could make the first one plus and make the second one negative.
Okay.
Yeah, or subtraction in the second one. So no, that doesn't make a difference.
Okay.
But what are some of the perfect squares? So things you're going to be looking for at the tail end of these are things like 1, because 1 is 1 times 1. 4, because it's 2 times 2. 9, because it's 3 times 3. 16, because it's 4 times 4. 25, because that's 5 times 5. And you're kind of getting the pattern there, aren't you? Because I want to have two identical things that multiply together to give me that last value at the end. And 36, which is 6 times 6. 49, which is 7 times 7. 64, which is 8 times 8. 81 is 9 times 9. 100 is 10 times 10. 11 is 121. 11 times 11.
What if it's not a perfect square?
If it's not a perfect square, then you can't factor it. Okay? So if you had something like x squared minus 32, I would have to say it's not factorable, because 32 is not a perfect square. Okay? So there is no perfect square happening in that part. So because it's not a perfect square, I can't factor it, and so I can just say it's not factorable. Okay? But if I had x squared minus 169, can I do that one?
Yeah.
Now, if you're not certain if this number at the tail end is a perfect square, you can go to your calculator and we can go on here and you can take 169, whoops, I need a square root, sorry. So I need the square root sign, so square root. If I square root it and it comes out to be a solid number, then I know, like that one comes out to be 13, so I know I have a perfect square. Now how do I know with my variable I have a perfect square? Well, in the variables, if the exponent is even, it is a perfect square.
If it's not, then not factorable.
Yep. Same thing. So if it's even, we know that it is a perfect square. Because if it were x to the 6th, that's the same as x cubed times x cubed. Okay? If it were x to the 8th, that's the same as x to the 4th times x to the 4th. But if it's x to the 5th, I can't do anything with x to the 5th because it does not break down and I can't get a perfect square out of it. So to finish this one up over here, I will have x and x, plus and a minus, and a 13 and a 13, and I am done. We use this a lot in intermediate algebra because what it is if I know one of these and I don't want to have a middle term, I can multiply it by the opposite or the other one, and that's called the conjugate, and we use it all the time in intermediate to solve some of our problems in there. So you want to keep track of that and realize that it's there with what you happen to have. So how about this one? If we have 3x squared minus 30 or minus 36. No. Minus, if I get my math right here, 27. There you go. What if I had that? 3x squared minus 27. What do you notice about it? Can pull a 3 out. So if I pull a 3 out, that leaves me with x squared minus 9.
And then just do x. Minus plus 3 out of front, right?
Yep. Beautiful. Yep. Perfect. Yep.
Wait, hold on. Wait.
Okay.
You start with the hardest ones. Because you know they're just
You like those, don't you?
Yeah.
Yeah. Okay. Notice. What was that?
It's 3x squared minus 27.
Yeah. Minus 27. That doesn't belong in there. Because 3 is common to both 3 and 27, I need to pull it out. Leaves me with x squared minus 9. X squared and 9 are perfect squares, so you're looking for that perfect square stuff in there. So if I got perfect squares, then I can end up solving that and coming up with what my answer happens to be.
When you pulled the 3 out, you didn't get a perfect square, would you just stop there then?
Yes.
Okay.
Yeah, so if you had something like 12x squared minus 48, for instance. Well, that's going to give me a perfect square. 36. Sorry. 36. So if I had 12x squared minus 36, I can pull out a 12. Leaves me with x squared. 3 out of 30, or 12 out of 36 is 3. And there's no perfect squares, so therefore I'd leave it. Now I would not put, that would be your answer.
I would. You would say not factorable?
No,
Or
you would
just
not
factor?
say not factorable because I did factor. I pulled out a 12.
So that,
Okay.
then that's just your answer.
That's just your answer.
Okay.
Yep. Yeah, because I can't break it down anymore.
Okay.
So that's as far as I can go with that one. All right.
Okay.
Yep.
All right, thank you.
Okay. So some of these you can, some of them you can't. Now another one that you cannot do, even though it looks correct, x squared plus 81. Looks like it's perfect squares, which it is. I mean, this is a perfect square, and 81's a perfect square. But if I go to try to do this thing, what happens? Well, let's see what happens. We get an x and an x, right? And to get a positive 81 at the tail end, that means I need to either have a positive and a positive, or I have to have a negative and a negative, because I can't get the opposite sign there at all, correct?
Yeah.
And the 81 is a 9 and 9. But when I FOIL this, what happens? X times x is x squared. X times 9 is a plus 9x. 9 times x is another plus 9x. And 9 times 9 is 81. But my middle doesn't disappear, does it? No. Changes my whole problem. So I cannot have a positive in here. So if perfect squares, but are added it is not factorable.
So it has to be a negative?
If you're going to factor, it has to be. Yep. Has to be a negative in there. If it's a plus and you have two terms, the only factorable ability with this is if you can pull something out of it.
Okay.
Because
So
I
then
cannot
you could
factor it.
Because then that would just be your answer, whatever you factored out
Right.
of it, and then that. Wait, what's the answer?
The answer is not factorable.
Oh, no, we were saying.
And it's not factorable because it does not have that ability in there to do that. Okay? So I cannot factor it. Okay? Will not work. Okay? So no, I cannot factor it, and so that's what happens to it. Okay. So just be careful with those and that you get your correct ones in there. The other piece that's in this one, and it's not as not quite as important if you don't recognize that it's perfect squares on every end, because it does factor the same as everything else. But it does save you time if you can recognize that you've got perfect squares within it. Because if we take a look at this one, 9x squared minus 12xy plus 4y squared, can I take anything out of there? Can I take anything out of there?
Yeah, no.
Yes or no? No, I can't. Okay, I can't factor anything out. So it looks like one of those big long ones that we've had before, which we could do it that way. But the unique thing about this one is that both the beginning and the end are perfect squares. Do you notice that? 9 is a perfect square and 4 is a perfect square. And because they are, that means, and if you can recognize them, it's going to be a 3x and a 3x. What's this one going to be at the tail end? And a y. Now, because this is positive and this is negative in the center, what's my sign's going to be? Negative and a?
No, negative and a negative.
Yes. Because the only way to get a positive is to have two negatives. What was that?
Well, just when you foil it.
When you foil it, it comes back. 3 times 3x is 9x squared. 3x times 2 is a minus 6xy. Negative 2 times positive 3 is a negative 6xy. Negative 2 times a negative 2 is a plus 4y squared. Notice your 12 came back in the middle. But you have to watch that the first term, so if the first term and the last term are perfect squares, place their perfect square at each end of the binomials and determine the sign. So you're going to look at that and you're going to determine your pieces in there. Okay? So you're going to look at your parts and you're going to say, if I've got perfect squares in there, I can break it apart. If you don't happen to recognize perfect squares and you're in there factoring it and you're working through this, you can do it the other way. You can take 9 times 4 is 36, x squared, y squared. And you know it has to multiply to give you 36, but it has to add to give me a negative 12. So what would my two factors be? 6 and 6. So a negative 6xy times a negative 6xy gives me my positive 36, and a negative 6xy and another negative 6xy gives me my negative 12. Replace my middle. So you can go back and do this the same way we've been doing it. It's just, it saves me a little bit of time when I don't have to do that, because now I got to take out a 3x. That leaves me with 3x minus 2y. Second piece, I can pull out a negative 2y. And that also leaves me with 3x minus 2y. And so notice it came out exactly as to what I had previously, but with more work. Okay? So if you can get in the habit of knowing squares, perfect squares, with this factoring. What was that?
Said you lost me.
Did I lose you?
Yeah.
Okay. I lost you. You were okay up there. Were you okay here?
Yeah.
Okay. And that's because each were perfect squares. When I lost you is when I got to the 6.3b, the method used in 6.3b, where you took the first term times the last term
Oh, yeah.
and got this, and then you went to find your middle. Okay? And I was just showing you that if you cannot pick out perfect squares, you can still do it this way. Yeah, you can still break it down this way, instead of going and looking for those perfect square things in there. Okay.
Is that okay?
Sure.
Alright, 8x squared is 18y squared. Because you can't, that's not perfect squares either, right?
Well, but look at it. What can I pull out? A 2 leaves me with 4x squared minus 9y squared. Now they're perfect squares. So now it's 2x minus 3y and 2x plus 3y. And don't forget your 2 you pulled out in the very beginning. Perfect square, perfect square. So you can have numbers in front. Okay? You can have numbers that pop out in the front of those things. So you still have your perfect squares in there.
Still speak Spanish, there's too many numbers and letters.
Yes, these have a lot of things in them. Yep, they do. Here's another one that goes with the ones we just got done talking about. But it's not in the right sequence or in the right order. Everybody notice that? My x squared is at the tail end. My numerical value is at the front. So if I just take this and reverse it, because basically I'm taking my sign, which makes that positive. My sign from my 18 made it negative. My sign from my 3, if I put a 3 there instead of a 1, makes it positive on the other end. Just an example.
Wow.
Yep. So what can I do to this thing? Is there anything I can do to it? Pull out a 3. Leaves me with 9x squared minus 6x plus 1. And again, do I have perfect squares?
Yeah. No.
Yes, I know.
You don't mess with that middle term at all.
Not when you're looking for perfect squares.
Nope, it's not.
Because you're looking for a perfect square here and a perfect square there. Only the beginning and the end. So is 9 a perfect square?
Yes.
Is 1 a perfect square?
No.
1 times 1 is 1. So
Okay, well, let me write this down.
3x and 3x, we all agree, right? 1 was 1 and 1.
It was 1.
Because it's a plus and a minus in the middle. What do I know?
Plus, minus, and the
Nope.
both
Negative,
both
negative.
negative.
Both are negatives. And don't forget your 3 you pulled out originally.
So what if you got, like, say your first number is like, say like, it's like a negative 9x squared. What would you do there?
Then I would have pulled out a negative 3 instead of a positive 3.
So it'd be negative 3 for both.
Yep. No, I pull out a negative 3 right here. I want this to always be positive. That first term, I always want it to be positive. So therefore I'd pull out a negative 3 out of there. Because I have to have it to be positive. This piece has to be positive. So if I'm pulling out a number and I've got all negatives in there, that's what I want to watch for. I don't even think they give you any that are like that. Oh, yep, here's one. Can I flip the page? Hopefully. What about this one? Negative 5x squared plus 30xy minus 45y squared. Can I do anything with that thing?
Oh, wait, hold on. I was. See, I don't know. I'm not gonna be able to sit by her.
Okay. What do we got? What can I pull out? A 5? Just a 5?
Y, X, I don't know.
What kind of 5 is it going to be?
Just a 5.
A negative 5, yes. A negative 5. And a negative 5 out of a negative 5x squared is x squared. Negative 5 out of positive 30? What kind though? Negative 6xy. And what about the 45? Negative 45, I can take a negative 5 out, I get a what? Y squared. Perfect. Can I factor that?
Well, you got y squared and 9y squared.
Single x squared out in front, so I can use my short method. What are factors of 9 that add to a negative 6?
3, negative 3, minus 3.
With a y with it, because I got a y squared. Don't forget your y. And don't forget your negative 5. Yep.
See, that's the one when you try and trick you when you put that y, because you get so used to not putting
Not having a y at the tail end. Yeah, they like putting that extra y in there. But again, if you do not recognize, notice this one had perfect squares. Did we talk about perfect squares? No, we just talked about factoring, because we talked about the x squared being single, so I put it out there. And then what were factors of 9? Things that multiply to give me 9, but add to give me a negative 6. We didn't do it by perfect squares with this one. We just kind of looked at it and said it needed factoring. And so I factored it. Okay, so you want to make sure that you end up doing that factoring stuff in there. Okay. Let's see if we can find another one. How about this one? Negative 20x squared plus 60xy minus 45y squared. Does that thing have anything that comes out of it?
Well, you can do 5 again.
What kind?
It would be a negative.
Negative 5. And then what happens?
Okay, so then you get positive 4x squared plus.
Will it be a plus or a minus?
No. Minus, because we're doing a negative 5.
What's a negative 5 out of 60? 12. XY. And
then that's when it turns to an addition.
Plus 9. With the y squared with it, right? Because that didn't factor out.
Okay. So we'll be able to factor out because we got the 4 and the 9. So we only be what? 2x on each of them.
Yeah.
And then it will be. Would it be a? Sorry, because that was a negative, so it both would be negative then.
Yeah.
And then it'd be 3y.
Perfect.
Or would it be y squared?
No, just 3y and a 3y, because it's the y is only squared.
Bring down your negative 5.
Yep, and don't forget the negative 5. Perfect. Yep. So if you can figure out that you've got squares in here, then you can do that simpler way of doing those. But if they're not squares, then I need to take the first term times the last term, multiply that, figure out what multiplies to give you the middle when the two factors are added. So you want to get that center piece going in there with those. Okay. Yes or no? You do another one? Are we good? You're good? Think you're good?
Yeah, I thought we're doing pretty good.
Okay. Alright, if we're good on that part, then we will move on to 6.4b. And 6.4b is factoring cubes. And when you factor cubes, this is where the formula comes in. Remember we were talking about before whether it had a formula or just a process? It just had a process before. But in factoring cubes, we need to understand what cubes are. So if you find the cube values that you happen to have, so if I take 1 and cube it, what do I get? What's 1 times 1 times 1? 1 times 1 times 1 is 1. What is 2 cubed? 8. What is 3 cubed? 27. 4 cubed? 4 times 4 times 4? What's 4 times 4 times 4? What was it? 64. Oh. 64. Yep. Times 4 again. Yeah, times 4 again. What's 5 cubed? 5 times 5? 25. And times another 5? You got 5 or 3. No. You have 5 25-cent pieces in your pocket. So what do you have? 125. Yep. How about 6 cubed?
216.
And 7 cubed?
343.
And 8 cubed?
512.
And 9 cubed?
729.
And 10 cubed? That'll be our last one.
We're at an auction.
To the highest bidder, we'll sell it, right? 1,000. Now these are your common cubes, okay? In this section, we need to break our bases back to what the base happens to be. We know if this is a cube, it breaks back to 1 to the 3rd power. If we have 8, the number 8, it breaks back to 2 to the 3rd power. If you have 27, it goes back to 3 to the 3rd power. If you have 64, it goes back to 4 to the 3rd power. And so we've got to be able to reverse these because our bases are what we need to fill in our formulas. If you have a variable in its cube, it will be x to the 3rd power, x to the 6th power, x to the 9th power. Because if I break this down, that's x times x times x. X to the 6th is x squared times x squared times x squared. And x to the 9th is x to the 3rd times x to the 3rd times x to the 3rd. So that's my main letter cubes that I could possibly have. The common one you're going to see the most is to the 3rd or to the 6th. They don't usually give you anything beyond that point within your cubes and what you happen to have. Okay? Now, when you do this part, the thing is that we've got to take a expression and break it back into what its cubed values would end up being. So everybody got this written down? Can I flip it? Okay. So if I flip it, the formulas that Hawks gives you are different than what I'm going to give you, but they're exactly the same. It's just letters. And I don't know, Hawks got into using X's and so forth within their formula, and it gets far more confusing than having different things. So the ones I like to use are a to the 3rd power plus b to the 3rd power. So that's what our original basic thing is going to look like. And let me give you an example. If I have x cubed plus 8. That's what it's going to look like. It's x cubed plus 8. Now the a and the b up here, a and b, are bases, meaning that I need to know what creates those letters. So a and b are bases when I work with this. So if I go to my example down here, x is already a base because it's just x. But 8 is not to a base yet, because 8's made up of what? If I wanted its cubed value, what gets cubed to give me 8? 2. So x cubed plus 2 cubed. Now I have bases because I've got my bottom values that everything is cubed to. So my bottom values are there. All right. So that ends up being my bases. Okay.
So we'll have a problem like x cubed plus 8, and then we're just gonna find what the cube is for 8, and that's our answer.
Then we need to factor it, okay? Because we haven't factored it yet.
Okay.
Okay? Yep, Scott?
I have a problem that has a cube in it, but
Hold off. Just hold off. Just wait. Okay? Because I want to go through this. I don't want to throw it in the middle of explaining this stuff. So just hang on to that for a minute, Scott. Okay? Because the formula to do this, and that's what we're going to get from up here is the formula. The first piece of my formula is A plus B. So it matches. Notice it's A plus B over here and it's A plus B here. So notice that part matches. And again, it's the bases that I'm looking at. The second part of my formula is I take the A value and square it. Opposite sign in here, minus A times B. And again, it's whatever A and B happen to be, plus B squared. Okay? And that's my formula that I use. So if I know that A and B are my bases, that's the stuff that I plug into my formula. So down here, my A in this case is x, my B in that case is 2, and so that is my pieces I plug into my formula. So I'm going to have x plus 2, because I replace A and B with x and 2. Next to this, I'm going to end up taking the A and squaring it, so x squared is x squared. A times B, x times 2, is 2x, and it's subtracted because it's the opposite sign of what I have in my cube. Finally, with the 2 squared. 2 squared is 4. Okay? So my answer is this. A, or x plus 2 times x squared minus 2x plus 4. This last piece that you find, even though it's a trinomial, it can never be factored. You'll never be able to do anything with that piece.
And that's just your answer, right?
That's my answer that I type into Hawks. Yep.
So, wait.
But you need to get this piece broken down to what your bases are going to be in there.
I got that part, so then you just put it into the formula. But when I was trying to put it in the formula, why didn't I get the x plus 2?
X times 2.
I got like x, I don't know how I did. I got like
Because
x.
when you're in your formula, you have A times B right here. So A is x and B is 2 for this problem. So x times 2 is 2x.
Oh, okay.
Okay? Yep. And then I just squared my last piece that's in there.
what if the coefficient?
Then you would end up having to do that coefficient and breaking it down at the beginning, if it's one that's a perfect cube. Yes?
How do you get the 4?
Took the 2 and squared it, because B is squared. So 2 times 2 is 4.
Oh, okay.
Okay? So you got to square whatever B is. Okay? So, yep. So if you had this, for instance, 27x cubed plus 8y cubed. So I first have to find my bases. I think that's what you're asking, Scott, with this type. So I still have to find my bases. So 27's a cube of what? What's 27 a cube of?
9.
Nope, 9 times 9 is way bigger.
Okay, well, see, hold on. This is where I'm coming in confused at. Because look, when I do 27 divided by 3.
You don't divide it by 3.
Well, how do you do it?
You want the cube root of
Well, how do you
27.
do a cube root?
Then you go to, on your calculator, you go to math.
Yeah.
You go down to number 4.
Oh, crap.
That's a cube root. Put in 27, close it in a parenthesis, and you get 3. Okay?
What number is that, Barney? 3, 4? Math, number 4.
So 27 is 3 cubed, and x is cubed already. What's 8? 8 is 2 cubed, and y is already cubed. We okay so far? All I'm doing is breaking them down to their bases, so I want to know what their base happens to be. So what's my a? Well, because both of these are cubed, 3x cubed is the first one, plus 2y cubed is the second one. This is my base, or that is my a. This is my base, and that's my b. Okay? And if I go back to my formula, and the formula was a plus b because it matches. A squared minus ab plus b squared is what I need to come up with. So if I match it, it's going to be the a part, or 3x, plus the b part.
2y.
Yeah. Then the second part, I'm going to square 3x. So 3x times 3x. What's 3x times 3x? 9x squared. We okay with that part? Then it's the opposite sign of what you have originally, so it's a subtraction. Then a times b, so 3 times 2 is 6. X times y is xy. So far so good? Okay. And then finally, square my b. 2 times 2 is 4. Y times y is y squared. And I am done. I think the hardest part with these is getting the bases. Figuring out what you have in your base values of coming out of these. Let's take a look at another one. 128y cubed plus 54. So if I put these guys on, are they perfect cubes? Math. Down to 3. Oops. Math. Number 3 cube. I put 128 in there. And I get, no, that's not what I'm supposed to have.
Yeah, I think
Math. 3, put 128 in. Close it in parentheses. I get a decimal number. So what does that tell me? If I get a decimal number? Not a perfect cube, right. So 54 probably isn't either. So do you put not factorable?
I would.
Oh, I wouldn't, because what do I have? Well, both are even on the end, right? So take a 2 out. Let's see what happens. If I take a 2 out of everybody, I get 64y cubed. 2 out of 54 is 27. So now do I have some perfect cube things going on? So now if I break 64, what's 64 is a perfect cube? 4 cubed. Y cubed. What's 27? 3 cubed. We've been doing that one. So my base over here is 4y cubed plus 3 cubed. So this is A, and that's B. And don't forget my 2. Yeah. Okay. So what's my answer going to be? Well, it's going to be 2. And then what?
4y plus, or is it just 4?
Nope, it's 4y.
Okay, 4y plus 3 cubed?
Nope, just 3, because it's your base.
Okay.
And then what's the second piece?
Then you won't have.
So 4y squared. Remember, I got to square my A. 16y squared. Minus.
AB.
Right.
4y times 3 will give us 12y.
Perfect. And then the last thing is going to be,
3 squared,
yep, which is,
9.
yep. And that's your answer. So they're not difficult as long as you get your bases in there and get your bases broken down. Okay? All right. So Scott, do you have yours you're asking about?
Yeah, there's a cube in it, but it's not from this chapter.
Oh,
I already broke it down.
okay.
Break it down.
Well, give me it. Let's see what we can do with it.
16 x cubed y times, subtract 28 x squared y plus 6xy.
This is not a really cube though, because notice you can pull out an x.
All an x squared.
You can't pull out an x squared, but you can pull out an x. And as soon as I pull out my x, that's going to become a square. Okay? I can pull out a y also, and I can pull out a 2. I can't pull out a 4 because 4 won't go into 6.
I just missed that.
Okay? So it's not really a cube. So when you pull that out of there, you're going to be left with 8x squared minus 14 x plus 3. Okay? And then it's a normal one to factor. It's not fitting into cubes. If it's a cube, it'll only have 2 factors. There'll only be 2, it'll only be a binomial. It will never be a trinomial if you're going to factor with cubes. Okay? So no, that wasn't a cube. That was a separate one. Yep. The other formula that you have, because not all of your cubes have pluses in the middle of them, some of them have subtraction. So if I have x cubed minus 27, for instance, that's going to fit a cubed minus b cubed in that format. And so its formula is similar to the last one we did, same basic pattern. It's going to be a minus b, because this part matches. So it matches that very first piece, so it's going to match this. And then the second part is a squared, opposite sign, so it's a subtraction, it's an addition. A times b plus b squared. Okay? So the only difference between this one and the other one we did was in the other one I had a cubed plus b cubed, which gave me a plus b, and a squared minus ab plus b squared. But the only difference is one has a plus sign and one has a subtraction sign. So that's the only difference between those. So you want to be aware of that with them, so that you get your 2 pieces in there. So if I finish the one I have up here, I'm going to have x cubed minus 3 cubed, because 27 is 3 cubed. So I would have x minus 3 for the first one. Yep, what's the second one? Is x squared. Well, it won't be minus, it's going to be a plus. Remember, it's going to be the opposite of the sign. And then x times 3 is 3x. And finally, it's still a plus at the end, and it's going to be 3 squared or 9. So that would be your answer to that one. Okay? So that would be my possibility of what comes up with that. So that's the piece of cubes. Let me find another one of those. What if we had 2 minus 128y cubed? Pull out a 2. Leaves me with 1 minus 64y cubed.
Wow, how do you do that?
Same thing. Get my bases. So what's the cube of 1? If I have 1, that's going to be 1 cubed, correct?
Yeah.
What's 64? 4 cubed with a y cubed. So my base is 1 for A. My base for B is 4y cubed.
So it'd be 1 minus 4y,
Mm-hmm.
and then you want 1 squared.
Which is? What's 1 squared? 1. 1 times 1 is 1. Easy one. Then I want to add, and I want to take a times b. So 1 times 4y is 4y.
4y
And then finally at the tail end,
plus
I want to square
squared.
b. So what's 4 squared?
64.
No, 4 squared. 4 times 4? 16. Y
Oh,
squared
4
is
squared.
y squared, of course. Don't forget your 2 that you pulled out at the very beginning. And so that becomes your answer.
Oh, crap, don't forget to do.
Now, these are formulas. You cannot do these any other way. You have to know your formulas up here in order to do them. They don't work. You can't factor them. You can't come up with another way of doing them. But knowing these. But if you realize the pattern, it's the same at the beginning, opposite in the middle, and then everything else is the same. It's basically the exact same piece for either one, but it's just your signs match at the beginning, different in the second piece, and everything else is identical for what you have. So it's not like you have a whole big bunch of different stuff happening there for those. Okay, another one of those? Are you good? One more? One more. How about something with a different exponent? We've been having cubes in here. Let's see if we can do something that 81x to the 6th minus 24y to the 9th. Let's see what happens with that one. Perfect cubes? Is 81 a perfect cube? Yes or no? 81 a perfect cube? 3 numbers times themselves that give me 81. No. Mm-mm. 81 is not. 81 is a perfect square, because 9 times 9, but there's not a perfect cube with it. So, pull out a 3. So if I take out a 3, that leaves me with 27x to the 6th minus 8y to the 9th. So what happens with this whole thing? Break it down to bases. 27 we said was 3 cubed. X to the 6th is x squared cubed, because x squared times x squared times x squared is an x cubed. The 8 is a 2 cubed. Y to the 9th is a y cubed to the 3rd power. Okay with that part? Then I need my bases, so it's 3x squared cubed, that's A. 2y cubed, that's B. And don't forget my 3 out in front. So my answer to this one is 3. 3x squared, yes. 3x squared, because I'm putting an A. No, it's a minus 2y cubed. And then the second piece of it, square the A. So 3 times 3 is 9. X squared and x squared is x to the 4th, so 9x to the 4th. Opposite sign, so it's a plus. What's the second piece?
A times B, which will be 3 times 2, give us 6. X, I don't know.
X squared, y squared. These don't combine when you're multiplying. It's 3
Okay.
times 2. And then finally, the last thing you need to put in here.
2 squares.
What's 2 squared? 4. What's y cubed squared?
Y to the 4th.
Nope. To the 6th. Yes. Y to the 6th, and that's your answer. So you gotta combine and do some stuff in there with those. Okay. Okay, 6.5 is review of the whole thing. So in 6.5, it's basically all we've done with factoring thrown into one big pile. It's kind of like a review. So we are not going to spend a whole lot of time in here going over stuff that is in there, but it does kind of pull everything back together that we have did so far with our factoring. So if I look at this problem and we get down to what our steps are going to be on it, can I take anything out of it? So that's the first thing I'm going to look for. Can I pull anything out of there? Can't take anything out? Well, I've got a number out in front, so that means I need to do that longer method. So 4 times 8 is 32s squared. So it's going to multiply to give me that, but it's going to add to give me a positive 33z. So what's my factors going to be? Things that multiply to give me 32s squared?
1 and 32.
1 and 32. So 1s times 32s gives me that. And 1s plus 32s gives me my 33. Now what? What do I have to do to that part?
You're going to put it back in the formula. 4
Yep, s squared plus s.
plus 1x plus
Yep.
32x plus 8. And you want to factorize it?
Yeah, s is in here. Plus 8. Group in 2's. And what can I pull out of the first one?
So we'll pull s out. So it'll be 4s plus 1.
And what can I pull out of the second one? Can pull out what on the second one? An 8. Yes. Gives me 4s plus 1. And so I factored it right because these two match.
So it's 4s plus 1 and then s plus 8.
Perfect. Yep. So that's what happens to that one. How about this one? 18x squared minus 8x squared. Yeah, they're s's. They're all s's in there. I had a z somewhere in there. Okay, this is an s. How about this next one? 18x squared minus 8x squared. Wait a minute, I gotta change the letter in there. I can't have 2 x's. This is a y. Pull out a 2? Leaves me with 9y squared minus 4x squared. I had to change that x to a y. I can't have both x squared.
Y would be 3 minus 2. And 2x, 2x.
Perfect. That's what you gotta have. Yes.
On these ones, on the test, if you write like that one in front of that one,
No, I'll make a difference. They'll be right.
Okay.
Yeah.
I always
Yeah.
feel like
Yeah.
that's
No,
the way
the
you-
order in here, doesn't make a difference.
Okay.
No.
Well, try to tell that to Deb, because I had fun. I tried to do that, and they said it was wrong.
No, it should be, something else is wrong with it. Because it will accept these in any order. So basically, if you're back up here, and you put into Hawks s plus 8 times 4s plus 1, it will accept it either way. So you don't have to worry about that.
How come you switch it every time? I always just do the...
When I do these, I always look for that common piece that I have in here. I pull it out first, because then when I pull it out of there, I'm left with the s. And when I pull it out of here, I'm left with an 8. That's the only reason. Yes?
I don't know why I just do it.
Okay, sorry, I lost you when I had a question.
Oh, that should be a 2.
Okay.
Yep, it should be a 2. I'm writing down things wrong. Nope, that should be a 2. That comes out of there. How about this one? What?
And then additions when like the last number, okay, so you have 3 terms, then the last number is not a term, it's squared.
Then you gotta go back.
Then you gotta go back and do it this way.
The 4 times 8, and then the 4 times, you get 32, the 32 needs to
Oh,
equal
that's the
33.
ABC.
Yes.
Oh, gotcha.
Or in this case, if this would have ended up being a 6 right here, I would just have to leave it like this, because I can't do anything else with it. With that one. How about this one? A squared plus 2a plus 2. A squared plus 2a plus 2. How about that one?
A, 2a squared.
A plus
So now you get 2a squared.
Now, let's try it here. You said an A and an A, right? And what are factors of 2 that are going to add to 2 in the middle?
1.
No, it's not gonna.
Well, 1 plus 1 is 2.
But 1 times 1 is not 2. So this is a not factorable. Yep, not factorable. So I cannot do that one at all. How about this one? 10x squared plus 66x plus 36.
Is that 66?
That is 66. 66x in the middle and 36 at the tail end. So, what can I do to it?
Somebody stole my brain.
What can I do to it? Can I do anything to it? Pull out a 2. Leaves me with 5x squared plus 33x plus 18. What's 5 times 18? What was it? 90? Okay. So 90x squared, but I need things that add to give me a positive 33 in the middle. 30 and 3? 30x times 3x, and 30x plus 3x is 33. Now what has to happen? Put them in the middle. Not of the middle way up above, but in the middle of the one you factored out your stuff with first.
I hope that's right.
Group in my 2's. What can I pull out of the first? Oops, an x, so I'll get an x plus 6. And what else can I pull out of the second one? Okay, so my answer is x plus 6 times 5x plus 3, but don't forget my 2.
Bring your 2 down. 5.
Yep. So this is my answer to that problem. Okay. And another one they might throw in there is x cubed minus 343.
So square root of 343.
Cube root, not square root.
Cube root, I meant. Okay, math.
Cube root of 343?
7.
7.
So x cubed, wait, what is that? X cubed, and then 7 cubed.
Yes. So what does that factor to?
X minus 7.
Yeah.
Then you want x squared.
Mm-hmm.
Is that minus
No.
An add,
Yes.
x times 7, 7x,
And last,
plus 7 squared,
which is
49.
perfect. Yep. Okay, but that's the stuff you run across in 6.5, because they pull all kinds of new information in there. Okay, so that's 6.5, and what you have to do with it. Okay. I think that's probably where we need to stop for today, because I don't really have enough time to do 6.6. I put it in here, but we won't do it right now.